I'm Dr. Karl Wyant. That PhD is from ASU, the reigning Big 12 football champions. That still feels weird to say. But thanks for having me. I live in Arizona. It's a little colder here than back home, but I'm surviving, and we'll get through this. So today I'm going to talk about science-based nutrient management for improved ROI. And this is part of our eKonomics platform. And that's, I'll have some more information about that later, but that's our agronomy research and resources that we have for you. And that's something that Nutrien provides. And the side that myself and Dustin DeMoss work on is the Nutrien side that produces fertilizer. So 26 million tons of fertilizer is in our production capacity from 2024. And that includes all the classic formulas, urea, 1034O, MAP, potash, and you name it. So if you're putting fertilizer on your field, probably using some of our products, and thank you. Just talking about this juggling act that we're doing on the roller coaster, right? Input prices, crop prices, weather, tariffs and politics have been a big newsmaker lately. Labor challenges, soil issues. Someone mentioned to me bankers yesterday, so I had to throw them on there. So hopefully none of you are a banker in the audience. But lots of challenges that we have to weigh and get through as we move into the 2025 planting season, as we're making our decisions for fertilizer. And one of these challenges that we have is, like, despite all this, we've got crop NPK needs that are constant. They are independent of all that's happening, on these squares here, and we're going to review that biology and show where your fertilizer is going and really how we can tighten up that fertilizer spend for 25 and put your dollars to work on the input side. So just to talk about nutrient demands 101, I grabbed the average yield for corn, 180 bushels an acre. I rounded up from the USDA average from last year. And just take a look at what kind of nutrient uptake are we talking about? How many nutrients in pounds per acre does it take to feed this corn crop? So nitrogen, you need 234 pounds of nitrogen to feed that crop, almost 100 pounds of phosphate, and about 250 pounds of potassium. So big numbers here. And that's what we think about with our fertility programs. We have the soil providing nutrients, and then we add in fertilizer to meet these big numbers. The challenge with our cropping systems is this is the uptake, but we're also removing nutrients at the end of the year with the harvest. And those are these numbers. We can look at the without stover. You're removing 126 units of nitrogen from the field, about 70 pounds of phosphate, and almost 50 pounds of potassium. So those are being exported off the field, and that's where we can really plan our fertility and our fertilizer additions to make sure that your crops are productive year in and year out. The Nutrien Agronomy team did an exercise a couple years ago where we were thinking, what's the future of crop removal for corn? And so we assumed a couple of things. Every year, we're going to increase our bushels per acre yield by 1.9 bushels. And so we did some pretty wild projections here. For 2025, we're predicting around 180 bushels an acre. By the end of the decade, about 188 on average. But if you go out to 2050, if this number holds true, 226 national average for bushels. And maybe in a few years, 25 years, come find me and tell me if my forecast was correct. I don't know. I'll be like in my late 60s by then, so don't judge me. I'll be doing something else, hopefully, on a tropical island somewhere. But if you just look at the nutrient removals, it just keeps accelerating. If you think about where your yields were when you started in this business to where we are now and to where we are going, this practice of really triaging your fertility program, I think if we start it now, if you haven't started doing it yet, can pay big dividends, because you will eventually have over 225 pounds of nutrients to put back every year on a corn crop. And if you think about that rotation with soybeans, think about that rotation with wheat, we can really start dialing in programs over the year. So I just wanted to review, where's my fertilizer going? I get that question a lot. I know I put it down on the ground. I know I've purchased it. Well, where's it going? So here's a red arrow that's already going to kind of tip you off. I'm going to show you a couple of places where your fertilizer goes. Also some great tattoo ideas for spring break coming up. No judgments here. Spring break city, Kansas City, right? But we'll talk about nitrogen. Nitrogen feeds the whole plant. And I think this is a good callback to yesterday's talk about the sunlight. I think the speaker said 3 million exajoules a year of sun energy hits the earth. Our entire energy grid produces 500 exajoules of energy a year. So lots of sun. Plants have the thing that can take that sun energy and turn it into something useful like yield, right? And chlorophyll is the way they do it. It's the pigment that keeps the plants green, and it's also the pigment that makes that translation, sun energy into biological stuff that we can use. And so if you've ever wondered where your nitrogen's going, here's actually the chlorophyll molecule. This is that tattoo idea I mentioned earlier. But there's your nitrogen going right into that chlorophyll from the soil, from your fertility program. That's what we're trying to do. No matter which crop you're growing, they all contain chlorophyll, and that's a big demand for your nitrogen fertilizer. We can keep extending this out into a couple more examples. When you're growing yield, even as a person, and you're growing, you've got to replicate your DNA to replicate cells. Well, here's DNA. DNA is made out of nitrogenous bases and RNA, so we need the actual nitrogen to create genetic material. If you've ever grown a crop and you're trying to grow protein, like say a durum wheat or some of our grain crops where you're paid on protein, here's the nitrogen in the actual protein. This is the basic building block of a protein called an amino acid. Every single building block of a protein has a nitrogen in it. So that's where your fertilizer is going. That's why your crop is so dependent on nitrogen. Chlorophyll, genetic material, protein. So basically everything a plant does, you've got to have nitrogen. One of the challenges with nitrogen is you've got this incredible plant demand for nitrogen. Just think of your fertility programs, how much nitrogen is the king of your nutrient management. But then you've got this incredibly easy way to lose it to the environment, right? This is just this state of affairs that we have. In a perfect world, we could get all of our nitrogen up into the plant and have 100% efficiency. Of course, that doesn't happen because of the loss pathways. It rains too much, we get nitrate leaching. You get a heavy rainstorm on some hills, you get runoff and erosion with your ammonium. It's too hot and dry, you can have your nitrogen blow off as ammonium gas. Or if it gets too wet with low oxygen, it can actually denitrify and blow off as nitrogen gas. So lots of demand, super easy to lose. That's a tough day for managing this nutrient, and it's incredibly challenging to keep this nutrient managed. And the real challenge is when we dial in our nitrogen just perfect, we get some really nice yields, right? This past summer I was out in Champaign, Illinois, perfect weather, perfect conditions. Even the most cynical agronomist lens I could try to look at the corn through, it was absolutely perfect, and they pulled off some record yields. However, then I went to north central Iowa on the same trip. Lots of rain, lots of nitrogen loss, lots of challenging looking corn, right? So here we see when we have great corn, what it looks like, and when we have those deficiencies, when those loss pathways are kind of exceeding what we're expecting. This corn looks like it's been chewed on by like animals or something, but that's just that failure to fill those kernels. What you can kind of see from the road here is just that yellow stunted corn. You know where it's supposed to be, you know what color it's supposed to look like, and you can just tell that corn doesn't look quite right. I'll go into some of my two favorite nutrients. Nitrogen is a big one, but I started off in the fertilizer world with phosphorus. That was my big focus, and it's still one of my favorites. But phosphorus is one of those nutrients where we talk about it a lot, but depending on where you go in the cropping world, some soils are just very challenged with phosphorus in terms of supply, in terms of fixation. Some other soils have it in ample amounts. So it's quite the management strategy depending on where you go. But phosphorus plays a role in photosynthesis and respiration. If you've ever tried to grow a seed or a fruit, like we're trying to do with kernels, any sort of grain, you've got to have phosphorus to fill that. And I'll show you exactly where. Energy transfer. anytime a plant has to pay for biological work, like to grow a root, grow a shoot, it has to pay for that work with a phosphorus-based currency. It's called ATP. I'll show you where the phosphorus is in that currency. Of course, it's important for cell division and enlargement. And we really think about phosphorus early on in that season. It's important for that early root formation, growth, and vigor. I'll give you a couple of details why. When you are in a super fast growth mode, you're trying to make these things called ribosomes in your cell. You are, and a plant is as well. And that's where you start to translate your RNA into protein. And so that ribosome is basically a big chunk of phosphorus. So you have a super early demand just to fuel that cellular machinery. But I promised you more tattoo ideas, so here you go. If you've got any sort of cellular machinery, plant or yourself, you've got to contain it with a membrane. Here's that phospholipid membrane. There's your phosphorus. There's where your fertilizer is going. If you've got a DNA or RNA, so you're growing, you're replicating your DNA, here's your phosphorus right there. It's the sides of the ladder. So if you think about a DNA as a twisting ladder, this is the sides. And then ATP, of course, this is that biological currency, how a plant pays for work. Like if you've got to make a crop, it's got to pay for it somehow, right? Nothing's for free. You're cashing in this ATP. You're cleaving these phosphorus oxygen subunits, and you're liberating energy along the way. So if you don't have enough phosphorus, you're really going to get cash strapped from an energy currency standpoint. So a couple of other examples, but these are your big three, and these can be in so high demand for your crop that, you know, if you have phosphorus deficiency, you can start to see it. And here we have that optimum phosphorus program. Here's that phosphorus deficient program. You can see that yield loss, not as drastic as the nitrogen, but you know, early on you get a nice signal here with corn, that purpling, especially under cool, wet conditions. Maybe not this cool and snowy conditions. I hope nobody's out planting right now. But early on in that spring, you know, mid-April, if you get some wet weather, you can see that purpling. I'll get into potassium next. And I'm going to disappoint you just right off the get-go. I don't have any good chemical structures to show you for potassium. If you think about where potassium is in a plant, a lot of it's in the liquid surrounding cellular structures, like the stomata and the leaves. There's the potassium that helps open and close the stomata. It's not embedded into a chemical structure like I showed for nitrogen and phosphorus. So you think about potassium, it's a little bit more of a wingman, but I don't have many good tattoo ideas for potassium. So if any of you think of some, let me know. We'll get that in the presentation. But what we need potassium for is photosynthesis. That shouldn't surprise you, this being one of the big three macronutrients. We've got to have photosynthesis happening. And then we've got to create sugars and carbohydrates. If you think about what we are harvesting at the end of the season, it's basically a packet of energy. Carbohydrates, starches, sugars, whether it's a grain, whether it's a fruit. And we've got to be able to move those sugars and carbohydrates from the plant into the harvested grain. So potassium helps do that, helps translocate starches and sugars. As a bonus, potassium is responsible for disease, drought management. I mentioned those little guard cells that are opening and closing leaves. When it gets too dry, potassium helps to close those guard cells on a leaf so you don't lose as much water. So there's your role of potassium. If you've ever had your corn or your wheat fall over, that lodging, potassium helps with stalk strength. And so if that's been a challenge, it's time to take a look at potassium. I had this issue, we grow durum wheat out west, and we have some strong winds in June right around harvest, and we had some lodging issues, and it was a potassium challenge. We fixed the potassium fertilizer, that wheat stood straight up the next season, and folks were happy. One piece, the potassium can help with winter hardiness, so that our winter wheat growers, they want to get that wheat crop through the winter. That potassium can help with that. And when you're under drought conditions, I mentioned that stomata opening and closing, that's water use efficiency. There's some great pictures from 2 years ago when we had a drought here in the Corn Belt of some potassium deficient fields and some potassium fields that had adequate potassium, and you could see a drought impact where you could actually see the potassium deficiency showing up when under those drought conditions, and the corn under potassium sufficiency looked great. They were getting through that drought without as big of a yield impact. One piece that's, if you're ever get into growing fruit and vegetables, like if you're out down in Florida or the Midwest, or if you might run a vegetable stand. One of our sales guys' parents run a vegetable stand out in eastern Iowa. They use that potassium to help make the size of the fruit. So they want like the right size zucchini. Consumers want the right size fruit, right? We're incredibly picky about what our fruit looks like, how big it is. Potassium is a crucial tool for that. And you can extend that into a corn kernel size, grain sizes. There's all sorts of uses for potassium, really based on its ability to help with moving sugars and carbohydrates within the plant. So I already disappointed you. Can't put this in a tattoo. If you think of a way, let me know. I'd love to throw that in my presentation. One thing we know is if we don't have enough potassium, we see that deficiency here, potassium optimum. Corn, if you squint hard enough, you can see that kernel size difference that's showing up, where the kernels that are on the optimum side, much bigger than those under the K deficient conditions. And we see that across multiple crops where there's a deficiency issue with potassium. It just really shows up in the sizing of the harvested product. Of course, potassium research and with deficiencies is nothing new. Here's a field in Alabama from 1958 that the International Plant Nutrition Institute did. And I throw this in just to show that this issue with potassium, especially on some of these lower quality soils, sandy, low organic matter, we can have some challenges with potassium. And here we applied without and with potash, we got a really nice yield result. So nice profitability there. Added the one missing element. It was the potassium. So this kind of gets me into my next part of my talk, and it's just talking about, I know I need NPK. I know I need a whole other basket of nutrients, but we're going to just keep it at NPK for this talk. How do I make sure I'm investing in the right nutrients? And that's a question we get often as an agronomist and as our team. Is like, what do I invest in this year? I've got all these changing prices. I've got changing political issues. I mentioned all those issues we have to juggle. I know I've got a biological demand for these nutrients that's not going to go away. I have to satisfy that crop demand despite all the other things. And I think that's where this idea of the triage comes in. And so I pulled some numbers from DNTP. This is just retail price per ton on nutrients. In this light blue, this is MAP. In the green is DAP. Urea is in this, Texas orange here. And then we have blue for potash. So these numbers change. Like this is the ranking as of last week of where these numbers are at across the fertilizer complex. But give it a few weeks, and that order is going to change in affordability. And so I think that's where this idea of soil sampling comes in, whether it's in the fall or the spring, and making these decisions, because it lets you think about your soil as a bank account, and you're investing in stocks. Like, right, these fertilizers, think about them as sort of stocks. Where am I going to get the most bang for my buck? So I want us all to channel our inner Warren Buffett here. And I got this off of Wikipedia, so thanks, Wikipedia. And just think about your soil as a bank account, and we're thinking about fundamentals. I've read a couple books by Warren Buffett. He always says, like, if you don't understand the company, don't invest in it, right? So I think that's where I think this soil sampling thing, it's like you can read the numbers, kind of know what you're getting into, and make that decision. So here's a real soil sample from a real farm, just showing various nutrients, and we have them listed here by name. We have the amount coming off the test, and then we have this nice color-coded ranking here to help us make a decision. So one thing I want to call out here is that these rankings can really help you triage your input dollar. What do I need to invest in this year to make my yield, and what can I maybe skip for this year if you're coming into some tight margins? And so one of the key things on this chart is this idea of this critical value, like this, what's optimum, what's medium, how do we establish those numbers? So I'll walk through that here very quickly. and then we'll come back to this as an investment sort of fundamental sheet. But this is the soil testing and investing sort of basics. When we have a soil test level, we can do the research to relate that soil test level to yield performance. And so after many trials, and I'll show you an example from Iowa, we can generate a bunch of dots of results where we have a dot for the soil test level and the yield, and we can actually make this curve. And so this is super informative because it can tell us, when we put our Warren Buffett hat on here, what to invest in, and I think more importantly, what not to invest in. So there's two key ideas here. When you're below this critical value, and it's just a number on the soil test, and you apply fertilizer, you're likely to get a profitable fertilizer response. When you're over it, when you're over that critical value, your likelihood of fertilizer response, profitable fertilizer response, diminishes fairly rapidly. So when we think about our Warren Buffett hat, don't invest money if your values are here, invest money here. And that's the triage approach, and that's something we've been getting calls on this and emails and through the agronomy team is, what do I invest in this year for 2025? I've got this changing index of affordability for my nutrients at the retail level. I've got a soil test. Where do I put my money? So we talk about this triage idea a lot because the contrast is just cutting the fertilizers by X% or X dollars. And what we found is that those nutrients that are way down here, very low and low levels, if you start cutting there, you can lose yield very quickly. And it can be quite a challenge at the end of the season. So this is basics of the investment here. And we've got some strategies we can deploy. Let's just pretend all your soil nutrient levels are high. You know, we can draw down those nutrients a little bit. You can weight some of those nutrients out, use them in the soil, use that savings account that you've established, grab those nutrients, put them in the crop, and then reassess for the next year. If you're way low, you'll need to get on a building program, and that can be challenging to accomplish in 1 year. So typically we can build nutrients from very low to this critical level if we take a multi-year approach. So kind of like a savings account approach, build those levels, and that's just your inputs of fertilizers and manures and cover crops are greater than what you're removing with the crop. So pretty simple math. When you get to this middle level, this yellow, that's where you got a little bit of fuzzy math, a little bit of ASU math that you can do, where it's like, you know, I could probably decrease that input a little bit, you know, and it probably won't hurt you because you're right around that critical level. You'll probably be okay if you cut back slightly. So you got a little more wiggle room if you're right in the middle here at the critical level. So I say maintain, but really it's fuzzy math. So you got some decisions to make. So here's how those numbers are put together. This is from Dr. Malorino, Iowa State professor, and just showing how they make these curves and establish these very low to very high numbers. Here's the soil test. Here's the relative yield for corn, and just showing that curve. Just showing that if you put so much fertilizer out that you get really high soil test levels, you are not going to get a yield response, a profitable yield response. So you're kind of just throwing money away at that point. Not a good investment, right? Warren Buffett, he would come to your house and say, hey, that's not the place to invest. But if you're down low and you're investing in fertilizer, look how steep that yield rises. You can go from a 55% relative yield and jump it to a normal 100% yield very quickly by making the right investment. Conversely, if you don't invest in these nutrients that are very low and low, you can decrease your yield very quickly. So you're on a knife's edge there. And that's where we've seen some of these cuts where people have come in and growers have come in and just cut their fertilizer programs where they've paid the price because they've cut the wrong nutrient. They didn't have that precision approach. So one challenge we're seeing is the TFI, Fertilizer Institute, does this survey every 5 years where they go into a whole bunch of soil labs across Canada and the United States. This is based off of like 2.2 million soil samples from across those regions. And they actually rank phosphorus here on how many soil samples were deficient in that state from those labs. So we're in Missouri here. 60% of the soil samples submitted in this state were deficient, below that critical value in 2020. We'll have a new test coming out. It is 2025. It's supposed to come out soon. Don't hold your breath. We just voted to make this happen like 2 months ago, so maybe 26. If you look at our neighbor Kansas, they're about 55%, but you go up to North Dakota, 77% of those soil samples are deficient in phosphate. So that's a good way to start kind of triaging here. What's a good investment? In these regions, phosphate might make more sense than others. But you go to Illinois, 31%. So that's a pretty low number. Pennsylvania, 21% of those soil samples. So now we're starting to get some wiggle room here of that absolute need for phosphate. I'll go to potassium. And here we're looking at potassium, say 2.2 million soil samples, and we're ranking them. Here in Missouri, 36% of the soils that have been submitted are deficient in potassium. Kansas is 20, so you got a little wiggle room there. But you go up to Wisconsin, 76% of those soil samples are deficient. So I know this is at the state level, but you can pull this idea down to your own farm and really triage what's happening on your ground. Maybe it's a challenging section that you've had a hard time pulling yield out. What's driving that possible yield loss, assuming it's a fertility issue? And then what can we skip? I'm from New Mexico. I know not every day down there is like Breaking Bad. But here we do not really worry about potassium fertilizer. We have 7% deficiency. It's just hard to find. But it's a mixed bag, and every region has its own challenges. And so that's where I think starting with a soil sample on your farm can be very economical. If you divide the cost of the sample by the number of acres that it represents, it can be very affordable and give you some good data. So we'll go back to our bank account here, our stock fundamentals. Here's my guy here. I would just say, when I look at this as an agronomist, I'm saying, what do I invest in this year, 2025? The biggest thing I take a look at, that potassium number. It's very low. We need to start building that up. It's nice that I showed that DNTP, those costs per ton. It's relatively affordable. So we can make that investment in potassium, and we know that we're going to get a high likelihood of having a profitable fertilizer response. And it also kind of starts setting up that soil to build the bank account over time. So 5 years from now, we might have a different story. Some other things that maybe I won't invest in as heavily. Phosphorus is medium. It's pretty decent. So I'll roll back my investment in that number. And then maybe I'll put some investments in boron as well and a micronutrient spray because that soil's low. So a couple things that I see that need attention first. Maybe a little bit of sulfur in the blend. And then we also had a nitrogen pounds per acre credit that we could throw into our nitrogen management plan. This soil is fairly rich, 3.3% organic matter, so it's got a decent supply of nitrogen in it, and we can account for that when we made our urea purchase. So just a way to triage here and make sure that you're getting out the right material on your farm and making sure that you are kind of going through this bank account system and really tightening up with that sharp pencil what you're putting in your blends. We took this potassium idea a step further. We did some grid sampling on this field. Now this is kind of an ASU grid where it's not perfectly square on the grid sampling, but we just that was how the farm was laid out. So what we found was that in a pretty large section of the farm didn't need any potassium. 40% of the acres didn't need any potassium. So we really just put it on this side and then across the bottom here, and we were able to dial in a pretty prescriptive fertilizer bill for this farm. So it's nothing new if you've been soil sampling for a long time, but I think coming into this season in 25, just worth another look of making those field by field recommendations and really getting that as much out of your fertilizer spend as you can. So just moving forward, I have this bullet point in here. NPK is non-substitutable. Like, you have to have it. And I say that not because a grower's ever asked me about this. Like, investors have asked me, can I just use something else? Like, if nitrogen's here, can I just use selenium and get the same impact? Sorry, investor, no, you can't. You have to have nitrogen. You have to, and then I show them the graphs, with the nitrogen and the chlorophyll. Here's why. They've never taken me up on the tattoo idea, but I also don't hang out on Wall Street. So it's just this biological fact we have to live with. It's that the plants have needs. We have to meet them to get the yields we want. There's no other way around it. One piece we saw in 24 was just fertilizer use reductions, and I've said this will be my third time. When we come in and we just start slashing those fertilizer budgets and we take out the wrong thing, it can be quite painful at the end of the season where we're missing yield targets by 15, 20% because we cut the wrong ingredient in the mix. And I think that's where revisiting these soil samples, if you haven't done them in a couple of years, can pay off when we come into this season. And so there's a triage approach. If you've ever gone to the ER and you've waited around a long time, chances are you're just not sick enough, right? They're triaging you. You're well enough that you can just hang out for a little bit because they're going to take the sickest people first, right? We're ranking them, how we're going to treat them. We're thinking about that with nutrients. What do I absolutely have to put out now and how much based on our data? And what can I maybe skip for this next year, and making that triage approach to nutrient management. So I think that comes into this planning piece. Spring is coming. We've already started planting corn across the Sun Belt. That started around Valentine's Day, maybe a little bit earlier for silage corn. But it's going to come. So if you're still planning those spring applications, a revisit on your soil data can help kind of tighten up those plans as we move forward. And what we're planning for is this fertilizer use efficiency. How do we get as much out of your dollar that you're spending on an input, put it in the right nutrients, put it in the right stocks, like if we're thinking about Warren Buffett, and getting as much value out of it. And this can also help with your product strategy, the other stuff, right? The other stuff that goes with fertilizer. Maybe there's some products that you're not quite sure of their return on investment just yet. Your soils samples can say, hey, does this product have the right fit for my field with what challenges I have? And maybe if those products don't fit, you can try something else. So there's a whole laundry list of these types of products, nitrogen inhibitors, these biostimulants, biologicals. Make sure that that product mode of action fits with what you're trying to triage here. And then, of course, good advice is key. And I think for folks that are new to the soil sampling world, showing someone these soil samples, it's kind of like when you go to the doctor and they start handing you those medical lab reports, right? It's just numbers. What does this all mean? I think that's where finding that colleague in your community, maybe at the ag retail level, and then I'll talk about our agronomy resources that we have here in a second, but just finding that good partner in the field that can just help you wade through the data and make some good planning decisions. That's absolutely critical. So just talking about 4R nutrients, and then I'll talk about our eKonomics resource. Right source, right rate, right time, and right place. And I'll just walk through like where some of these strategies for really kind of having that sharp pencil for 25 on your inputs. Of course, I'm going to mention soil tests a number of times. We want to apply only what you need. So if you have anything in that blend that didn't make your triage list, it's time to think about cutting it out for this season. And then also your formulation assist. That's the extra stuff that we put in blends. Make sure it's working for your field and it's actually addressing your triage program. We have the right rate, so how much. Those soil potassium rates that I showed you for that field, very, very low. They needed a lot of potassium this year, so we made a plan, a 3-year build plan for that season, for that field. And so we're actually able to come back and remeasure and see how our potassium stocks are looking because we know what to invest in. We can align that with yield goals, and of course we're trying to avoid over and under application. And so the under application, I mentioned that for potash, on that sample, they needed a lot more potash than they were using. They weren't matching their removal rates with the crop, and so we were able to make some tweaks, put some dollars into that section, cut some dollars out of some others, and they're very happy with their program. Of course, we have right time, put out the fertilizer when the crop's going to use it. Every fertilizer behaves a little bit different, and hydrous has its timing when we use that for nitrogen. Urea and ammonium sulfate have their timings, and just make sure that if you're new to a fertilizer product, that you're putting it out when a crop can use it. so we're not losing it to the environment. Because that's another way to waste dollars, right? Is if you lose it to the air, you lose it to the stream or the groundwater, not a good way to get efficiency out of your fertilizer. Then, of course, we have the right place. And if you go onto the agronomy chat rooms and message boards online, this is a lot of debate here about how do I put the fertilizer out, band versus broadcast, soil placement, liquid options, foliar options. I don't want to debate that here on stage. What I want to say is find that fertilizer that you need on the field because you've got the data, right? You've got that precision approach to your fertilizer plan based on your soil data for your field and your farm, and we can figure out later on what's the best way to get it out. And so having those conversations with your advisor is important, crop advisor, and if they can give you that good advice on which is the best formulation of nutrient, I think starting with the triage is a great way to focus that attention onto which nutrient you need.